Hello, everyone, and welcome to this new session for the ERNI Frontend community. As you may notice, I'm alone today because David had just got married, so congratulations to him. This is a really nice talk about node streams, this gray area that when we start working with Node, you see about this node string, a chunk, you don't really know what it is, but it's always a good idea to uh, learn yourself these powerful technologies, because when you need it, it's really a good thing to get to know them. So without further ado, I will share my screen. Rafael will be talking about the node stream. So Rafael, go with it.
Okay. So thank you for having me here, first of all. My name is Rafael again. Been working at ERNI for quite some time right now. Today we are going to be talking about node streams. So first of all, disclaimer is that as much as we try to extend the time that we have today, it would be basically impossible to explain everything about node streams. So we need to take that into consideration. This is going to be only like the initial part of the node streams module that Node provide us. Second part, that's some stories that are told here are not completely real. So yeah, take them with a grain of salt. And third, this presentation was basically fueled by Monster Energy drink and a lot of my ADHD. So yeah, you may see that in the stories as well. So without further ado, let's start this presentation. And nothing better than getting started with a small story about a dude, right? And specifically this dude. And you may think, okay, why are you talking about Vin Diesel? And I could say, why not? Like the dude jumps from the top of a car that is jumping from the top of a bridge. It's basically a jump recursion. He's also a pretty good citizen. Like he's giving directions to this police officer here, and he's making sure that he will get to the right place. He's also a man of family. He does everything for his family and everything in the name of his family, and he's really about family, you know? And last but not least, a lot of people say that imitation is the biggest form of flattery. So here we can see a lot of people imitating him. So he must be really good at doing stuff if he has that much people imitating him, right? So yeah, he's pretty good at doing things. He's almost a 10x engineer in terms of productivity, right? But what fuels him? When we are talking about humans, for example, we are talking about water and food. Like we need water and food to exist. When we are talking about programmers, we are talking about Monster Energy drink, of course, coffee, and ping pong tables in the office. Without those, we can't live. And when we are talking about diesel, Vin Diesel needs diesel. And yeah, this image was definitely not AI generated. And just kidding, it was. But lately, he's having some supply problems. And why is that? Let's take a closer look at what's happening. So here we have a 50-liter tanker. Okay, so it has 50 liters of diesel inside of this tanker. And then we have Vin Diesel's deposit that only has 40 liters of capacity. Same way that trying to put more water in a bottle that it can hold, like it ends up spilling. And what will happen is instead of having a full deposit, you will end up with a broken deposit or with a spilled bottle. And that means that our dude here isn't drinking enough diesel to be buff again. And yeah, we like the buff diesel, not the skinny diesel, right? So we are developers. And when we look at things like this, we say, okay, there's a way to fix that. We can fix the stuff. And what we do is we find the fix. Okay, so we stay all night trying to figure out what's happening. And of course, when we find the solution, we present it to our product manager. Initially, the conversation goes like this: like, okay, we are going to refactor the distribution system. We really found a problem. Some of our customers are being affected by it. And yeah, it should take only 1 week to complete it. Shouldn't take much time at all. And usually the reaction of the product manager or product owner is usually like this. Oops, sorry. Is yeah, sure. Why not? Uh, and 1 week later, we get the new implementation in production. So now instead of driving the oil tankers, the diesel tankers, we have a factory with direct on-demand distribution. And now instead of like having to hold 40 liters of diesel at home, he only needs to hold 10 liters because it's always available and it's on demand. It means that the deposit is always available for him to use as much diesel as he wants. And now he's back again. Like he's even younger, like he's even buffered than before, and smiling. So okay, but what is this like a talk about Vin Diesel? Is this what is this that we are doing here? What does it have to do with node streams? And I need to talk to you guys that yeah, it always been about node streams. So now let's take a look at that same story, but from a more technical side. Okay. So stream versus in-memory buffer for when we are consuming a file. So we have this 24 gigabytes file here. We are storing the file in the buffer in memory, but our server only has 12 gigabytes of RAM, and of which not all the 12 gigabytes of RAM are for our application. Some of those gigabytes needs to be used for something else. And what happens is when we try to load this file in buffer, like we do not have the necessary memory to do that. And yeah, our server explodes right away. And that leaves us with an angry customer. He doesn't like the server is exploding. He can't access the application. And yeah, he's angry. I mean, I would be angry. And here on the bottom part is the on-demand distribution. So reading this file in chunks. So here what will happen is we will read small bits of the file, okay? And we will do the process that we need, like the transformations, the processing of this data, only to those small bits of the files. And then what happens is that at the end, we can have our whole file processed without issues. So the server is even sparkling and the customer is happy, right? But okay, what is a stream? Uh, a stream is a continuous flow of data that can be processed incrementally as it's received and stored in a buffer while waiting to be processed. So, okay, we receive data from somewhere, we store it in a buffer, and we process the data from the buffer to the next part. Okay, and when we are inside of Node.js, we are usually talking about the 4 different types of stream: the readable, the writable stream, the transform stream, and the duplex stream. But now we may think, okay, what each of them do. So let's understand it better. So let's get started with the readable stream. The readable stream acts like a waiter, bringing the dishes that you want to the table one at a time. So you don't need to wait for the entire meal to be ready. Uh, and yeah, you can enjoy each of your dishes as it arrives. So you have the starter course, the main course, and the dessert, like one at a time. No, not all at once. And it also allows you to choose when the plates are brought to the table. So, for example, if you want the plates to come to your table as soon as they get ready in the kitchen because you want to eat fast and get out fast because you have a lot of appointments, you can ask the waiter to do this. But you can also take your time, enjoy your meal, and yeah, eat more sparsely the different courses, and yeah, get home happy after that. But cool. How can I create a readable stream to get started with? So we have different methods of creating a readable stream. First off, we can instance the readable method from stream, like in the first square in the left. We can also create readable from iterable, and this is really powerful because it's not only an array, it's everything that implements the iterable. It's basically everything that implements iterable. You can call it here. I'm using an array as an example. And we can also convert a web string into a string. So there are some methods inside of a browser, for example, that returns to you readable strings, web readable strings that we can convert by using this from web method here. Quite easy, and then we can use all the APIs inside of the readable. And we can also do it in the old-fashioned ways, extending the class readable and then implementing the methods there inside of our own class that's extending the readable class. And you can also use the methods that are already provided to us that are native from Node.js. So one of the examples is the create read stream. So when we want to read a file from our file system and we don't want to like store all the data inside of memory to then start doing something, we can use it and we can read from it like this. And one important note here is that, for example, when you're using fetch API, we have the response.body and response.text. They provide streams, but they are not readable streams. They are web readable streams. So we can use the from web that we just seen to convert it to node readable streams and yeah, use all the features that we are seeing here. Cool. Now let's talk a little bit more about how to implement our own readable stream. So the first thing that we need to understand is the internal read function, so underscore read function, and the stream.read function. First, we need to understand what is the internal read function. So in this case, the one that is getting passed to the new readable here. We have the function there. We are passing a function to it, and inside of it, we have readable.push, and then readable.push no after that. So first, we need to understand what this function do. This function acts as a data retriever. So if you want to have, for example, data pulling from a stream somewhere else, like a WebSocket or something like this, you can put it there. It will continue to do the thing, continue to retrieve this data for you to consume somewhere else. So this is like the dude behind this, the curtain is like getting the data for you. And we also have this readable.push no here. This readable.push no means that the stream has ended. So when we push no to the stream is over. We can get our stuff and go home because nothing's coming out of it anymore. Okay, so read inside of the new readable data retriever. We also have these two other parameters here that are the object mode and the high water mark. So those are really interesting because the object mode here allows us to read the data as it is pushed. So for example, here we have the object mode true, and we are pushing heyo. When we get to consume this heyo data, we will be able to consume it as it is, as a string. If it is not object mode true, it is false, that is the default mode, then what happens is that we will be consuming a buffer with this value. So we would need to parse it to a string to then consume it as a string. And the high watermark here that has a 4 on it, it's basically the size of your buffer. So remember that the string has a buffer, and then we read from the buffer. This is basically the size of it. If the high watermark, if we have object mode true, the high watermark means the amount of objects or the amount of stuff that can be written inside of our buffer. So in this case, I can push heyo 4 times until the buffer is full. And if it's not an object mode true, it's false, then it's basically a size. So we need to put how many bytes we want there. If we want 1 kilobyte, then we put 1024. If we want 16 kilobytes, then we put like 1024 times 6. And yeah, that's basically how it works. So this is the internal read function. We can call it internal or underscore read function. But what about the external one, the one that is here in the bottom, readable.read? This is the function that reads from the buffer inside of our readable stream. So in the example that I was telling you before, if the object mode was false here, and we perform the readable.read, we wouldn't be receiving heyo here. We would be receiving a buffer that would be needed to be parsed to a string to then get the heyo value. And then later, when we push no, it means that, yeah, we'll not be reading anymore from the string. So every time that we try to read from it, it will be no again. So cool. Readable.read reads from the stream buffer. Internal read pushes to the stream buffer. But now, if we remember correctly, we had this whole deal of bringing the plates as fast as possible, or like pausedly eating our food, enjoying the pleasure of eating. And this is why I was talking about this. When we are talking about a readable stream, we have read modes. By default, it is when you start a readable stream, it starts in paused mode. And paused mode is basically you ask for the stream to give you another chunk. Every time that you want, it will not consume the next chunk inside of your buffer again if you don't ask for it. And the flow mode is basically the mode that tells, okay, dude, it's ready, give me, it's ready, give me, it's ready, give me, it's ready, give me. So it consumes all the data inside of the buffer as fast as possible and as soon as possible. And how can we access those modes? So the pause mode, for example, the thing that we need to do is call readstring.read, right? So when we call readstring.read, we get the last chunk of data that we have in our buffer, and we provide it in this way. But for the flow mode, we have the readstring.onData event listener. So we listen to this event, that is the data event, and then we have a callback. Every time that we have a new thing in our buffer, it will be there available for you to consumption inside of this callback as a parameter to it. Same thing with pipes, and this is one point that I really want to stress out is that pipes are really, really important for the whole stream thing. So if you start paying attention at pipes right now, it's going to be really lifesaver in the next part of the presentation. So here we are doing a read string.pipe writable string. When we have a pipe, we can pipe something like usually something up. We can pipe a readable string to a writable string, because this way all the data that's inside the readable string buffer gets piped to the writable string. So all the data that is passing through the read string that is generated on the internal read is passed through the writable string, and then we can do whatever. We can write it to anywhere we want. But cool, like let's say that I want to not stay in flow mode anymore. So I have this piped read string, but I want to now read it more pausedly. So yeah, there are two methods that can help you getting back into the pause mode. There are the unpipe, that is when you don't want that string to be piped anymore to somewhere. And you also have the readstream.pause, that is when you want to pause the execution of those flow mode methods. Yeah, it's basically like this. And if you have one of those methods attached and the stream is paused, then you can resume it. And then it will be back into flow mode, no problems. Cool. But now let's talk about the state of the readable stream, right? So we've seen like this paused mode and this flow mode. And basically the state of the readable stream is the representation that tells you whether the stream is in flow mode or in paused mode. And to access the state, the stream object provides you a property called readable flowing. So you can call readable.readable flowing, and it will yield you three values, null, true, and false. So what does this value mean? Let's get started with null. So when it returns you null, it means that you started the string, so new readable there, but you weren't doing anything. Like you didn't apply a read function to it, you didn't give a read function to it, internal one, you didn't attach something to consume data from it. So it's pretty much there existing, stale, and yeah, it's not supposed to do anything. So it returns you this null value. When you have true, it means that you have the stream initiated. So yeah, new readable, and you attached some of those mechanisms like pipe or on data to it, and it means that it's being actively consumed. So it's pretty cool that it tells us with true that okay, we have those mechanisms, they are active. And false means that we either had one of those mechanisms initiated and we pauses them or unpiped them, or we didn't put one of those mechanisms, and we are just reading the data through .read and controlling the flow ourselves. So now let's talk about back pressure. Like back pressure, what is this? Like back pressure is basically an event that happens when the producer is sending more data than the consumer can consume. So here we see that like the stream buffer is full, and because of this, like the internal read function can't push more stuff into the stream buffer, right? So, and we have this chunk like being read here by the consumer. And yeah, it's a slow consumer, like it only consumes a chunk once upon a time. So cool. Let's say it finished reading this chunk. So what happens is we can call as read again. So we will start reading a new chunk. And then a space on our buffer is empty. So it means that the internal read function will start running again. So this all happens around the buffer. If the buffer is full, it will not retrieve more data. If the buffer is empty or have space, then it will continue to retrieve data from whatever place and putting the data in there. And now let's take a look at the implementations like that we were talking about before. So we have the 24 gigabyte file being read in chunks. So here's basically a readable string.on data, right? Because we are reading this and we want to read it as fast as possible. We don't want to stop the execution for anything. Yeah, we are doing a callback here to do something in the server, right? And here we are talking about the factory with direct on-demand distribution. And as we are talking about the deposit with a certain capability here, we can't for now do, for example, on data, because otherwise it will continue to get the diesel from the factory and we will end up with skinny diesel again. And that's something that we don't want to happen, right? So to make that work, getting back here a little bit, right now we aren't like putting this data anywhere. We're just reading it from somewhere. So how can I make sure that this data that I'm reading, I can put in somewhere, in a file or in a, I don't know, in a database, whatever. And that's when we need to write this data. And we can write this data with a writable string. So a writable string is just like a hose. Like you can use it to fill stuff up. So for example, if you want to get the pipe from the factory and like put the diesel on a hose and like fill the diesel drum, you can do it. If you want to fill a bucket, you can do it. You can do anything that you can fill anything with a hose, right? So it doesn't care about where the source comes from. As long as you're writing with it, it's cool. And it also has flow limiters and lets you know when the pressure is too high that it might cause a rupture. So in this case, for example, when we are filling a bucket, like all were children, we all filled buckets with hoses before. So when the bucket was almost full, like sometimes we would put the finger at the end of the hose and like, okay, we don't need to fill it anymore. So let's hold it here, and then like we can wait until we need to fill another bucket or something like this. The hose would still be full, right? But it wouldn't rupture. And we could like control the flow of water that way. Cool. So enough about hoses. Now we can talk a little bit about how to create the writable streams. So with writable streams, we have simpler methods. So we only have two in this case. We can implement a class that extends the writable, and then we have the underscore writable method inside of it that is our internal write. And we also have the write method that we can pass to our instance of the writable, just like this. And we can see like some fellows that we've seen before, like the high watermark and the object mode here as well. So both of them are here, and yeah, they will be basically in all of our streams. And yeah, like writable streams are also in a lot of different built-in modules in Node, such as, again, in file system, that we can write to a path quite easily by creating a create write stream. So we just indicate the path of the file that we want to write to, and it will provide us with everything that we want to write. We also have the process.std so we want to write something to the terminal. In this case, like log stuff that I want to write to the terminal. So we can do it quite easy. And also when we create a server from Node.js, the response method is a writable stream. So you can write to it, and yeah, pretty cool. But now let's talk a little bit more about the implementation, just like we talked about the implementation of the readable stream. So here we still have, as we seen before, the object mode, and we have the high water mark. So we can define this same way that we did in the readable stream. But here we have two different methods. Like in the readable, we had underscore write, that it was the underscore read, that was the internal read, and the stream.read, that was the external one. Here is a little bit different. So let's get started with the external first. So writable.write chunk here, the last line in the north. So this writable.write chunk is a function from the stream object that is used to write to the stream buffer. So before, in the readable stream, we remember that the internal function was the one that was writing to the buffer, right? So here is the opposite. Here's the external function that's writing to the buffer of the stream. And in this case, when we are writing using this function, it returns you a Boolean. So it could be either true or false. And this is very important right now. It's a really important part because if you don't handle this correctly, you can break your entire stream module. And yeah, not good. So when you do writable.write and it returns true, it means that the buffer still has space and you can continue to write stuff there. Okay? So while your writable.write is returning true, it's cool, you can continue writing. But when it returns false, it means that your buffer is full. And if you write data there, it will not be saved. And yeah, you will be ending up losing data. So in this case, a way to determine if the writable stream is available to be written again is to listen to the writable.onDrain event. So you can always put the callback at the back here. So when the writable buffer gets drained, then you can the callback will be executed, and you can like start writing to it again. Pretty cool, pretty easy. And we also have the internal write function. That is the function that we pass to the new writable, or we write it inside of our writable as underscore write. And this function, it has three parameters. So first is the chunk that we are writing. Second is the encoding that it's reading into. And also the callback, the third one, the callback. First, you can write the chunk to whatever you want. For example, if you want to write this chunk to an array, you can like array.push chunk. Okay, it's fine. It doesn't like have any kind of discrimination against where you should write to. You can also write to a place that is a database or do asynchronous operations and anything else. The most important part here is the callback. And why the callback is so important? Because it's the callback that lets the writable stream know that that write operation has ended. So what happens if you don't put a callback there? Your writable stream will have a write that will go forever and ever until the application isn't stopped. And yeah, we don't like forever going things when we're talking about applications, right? Unless it's like the reliability of our application. So if we want the write to go through and start on a next write, then please put the callback there. Is the thing that will let you know that the write has finished. So cool. Like now let's see a little bit more about the back pressure thing here, right? So we don't want to overflow the barrel that Vin Diesel has at home. Like we don't want to destroy its home again. So yeah, we have the back pressure here, and it happens when you can't write as fast as you receive data. So again, we have the stream buffer that is full. We have the internal method write that is running and it's writing the chunk. And when we try to run s.write here, the stream buffer is full, so it returns false, right? And right now, for example, we have the chunk reading. Just finished this operation that was running here. The callback function is executed, meaning that, okay, we finished the write, and the event, the drain event is called, meaning that we have space on our buffer to start writing again. So when this happens, we have the write function starting to write this new chunk of data that just have been emptied from the beginning of the buffer. And when we try to execute the stream.write, it will return true because now there's space. And yeah, we'll be writing the new chunk, and we can get a new chunk in there as well. But now it's a cool part, like piping it up with readable pipes. So we see this whole like diagram here with, okay, we have the s.write that is false, the drain event, writing chunk. Yeah, the write is true now. This is like really a lot of effort, like to handle this kind of state, right? And here's where the pipes enter. So when we talked about the flowing versus the pause state of a readable stream, there was this method called pipe. And the pipe method allows you to add a writable stream to a readable stream as a consumer, meaning it will consume the data that is being read. And with a bonus, it handles most of the back pressure for you. So in this case, you can pipe your write stream to a readable stream. You'll get all the data that is being read into the buffer of the writable stream. And then you don't need to handle that back pressure thing like that. Okay, the buffer is full, so I need to listen to the drain event. No, the pipe has its internals. In its internals, it listens to it and controls it for you. So here, let's take a look at the what is written here. So we have the readable stream, we have the writable stream, and we have the create write stream here. Cool part is that the create write string, it's already a writable string, so we don't need to worry about implementing that. And okay, so we have the new readable. The new readable pushes instead of the read hey yo and hey ya with a new line in the end of each. And when we execute the pipe, readable pipe write string, what will happen is it will create a file in the path that we determined, and it will have the inner value of heyo and in the next line heya. So it's that simple. Like it basically allows you to pipe stuff, pipe strings, so you can perform this kind of operations. Cool. So now let's take a look at the new functionality, new flow of action. So we have the 24 gigabytes file now, and we are still reading in chunks, right? So readable, but now instead of listening to the data event, we are piping it to a writable. In this case, it could be the create write stream, right? And it would be sending and writing the file into our 12 gigabytes server. So cool. Now we have some way to write it. And here in the Vim Diesel situation, we have the factor with direct on-demand distribution. And yeah, the same thing here, readable stream.pipe, writable. But here, for us to do this, we would need to have some kind of control flow implemented so it wouldn't get past the capacity of Vim Diesel's deposit, right? We don't want to end up with the same thing happening again. And yeah, we see here in the bottom right that we have this dude here is pretty sad, right? So he doesn't look okay. He's asking for help. So let's take a look at what happened. Like, and yeah, something went wrong. So let's dive into it. Okay, so we did all that refactor. And the thing is, we did that refactor so good that now the stakeholders decide to change the material that they deliver to oil, so they can like have more clients and don't need to handle the refinery again. Thing is, our dude Vin Diesel here has a 10-liter diesel capacity, so now he can't drink. He can't drink his diesel anymore, and his deposit is again all broken because yeah, that's viscosity. Everything is wrong with oil, and thus because of that we have skinny diesel again. And as I said, like we don't like skinny diesel. We want the buff diesel back. So luckily we have a solution. And we will need something to transform that oil into diesel again. So right now we can get started with transform streams. So the transform stream is like a refinery that receives raw material, transforms into refined material, and then provides the availability for its consumption. It's a mechanism that you write, modify what's been written, and read the result of the modification. And it implements both writable and readable interfaces. So it's pretty cool, really powerful. Transform stream, two ways to create it, extend and instance it. Pretty similar to the way that we create the write streams, right? So here we have the new transform, then we can pass a transform method to it. And also the same thing if we want to extend the transform string, and we can then add an underscore transform to it. It's basically the same thing all over all the streams. You can also always extend the stream and then create your own method. The only thing is that when it's extended, it's with an underscore. When it's not, it's without the underscore here. Same functionality though. Nice. And the transform stream also have some native modules that use transform streams as a base. And two great examples of that is the zlib.create gzip. So what happens is that you can write to this create gzip function here, this transform stream. Then inside of the stream, it will transform it into a gzipped binary, and then it will be able to read that gzipped binary. So it does all of the stuff inside of it. Write, read, write, transform, and read. Same thing with create cipher. You write to it the data that is not ciphered, it will secure it, and then you can read the data already secured. Pretty cool. So implementing our own transform stream. So write, transform, and read. And as said before, the transform stream implements both readable and writable streams, but with a spice. The transform property. It allows you to send data through the s.write. So let's go here to the example on the left. We do transform.write. I hope to be transformed and made available to s.read. So to be transformed, where is this transformed? Inside of the transform that we pass here inside of the new transform. So it's almost the same thing as the signature is almost the same thing as the write function, the internal write function, with the chunk encoding and callback. But it also has this this dot push here that is from the readable stream. So what happens here? What happens is that when we write the transform, it goes directly to the transform, and when we push inside of the transform, it goes directly into the readable string buffer that is available to be read anywhere you want after it's pushed. So here in the example, I whole gets written, goes to the transform pushes chunk.toString.to uppercase. So it transforms it into a string, transforms it into uppercase, and that's one at the end. And when we want to read it, it will come back everything in uppercase with a one in the end. Cool. So let's see like how is the flow like more illustrated right now. So it goes basically like that. We have the transform.write. It writes into the writable string buffer. Then the underscore write function writes to the underscore transform function, in which we push the transform data into the readable string. And then when it's in the readable string buffer, we can consume it through s.read, s.pipe, or s.onData and do whatever we want. So this here is really powerful. Like we can transform anything we want, anything that we write, and already make it available for reading. And yeah, like this whole transform thing, like we can transform things that we write and like make it available as a read. So this should fix Diesel's issue, right? So let's see how the implementation is going to be. So now we have the factory with direct on-demand oil distribution. And now we have this little transform here that is going to transform the oil to diesel. And now he can read and write it the same way that he was doing before. And yeah, it still has this 10-liter capacity deposit here. Deposit is always available. And again, happy diesel. So now the cool part about the transform strings. This is really where like things start to get together. Like it's really cool. So piping it up 2.0, multiple pipe operation. So we talked about pipe before, but it's in this setup that it really starts to shine. So a transform string implements both writable and readable streams. Hence, it has access to the pipe property from the readable stream. right? Just like we seen here in the little diagram that I did. So s.pipe. So we can consume the data from that buffer through pipe. So when paired with the right transformer read flow and with the back pressure handling from the pipe itself, so we don't need to care about the back pressure here. It's already taken care of for us. It becomes really easy to work in our Power tool for processing the data incrementally. So now let's see an example. Oh, it's cool. So here we have our readable stream. So readable stream from, and here is an iterable. So really important stuff here. It can get in wrong hands. So for each not getting wrong hands, we need to like secure it and make it small, right? So it's easy to store as well. So we have the gzip functionality. It's already known, really easy. And we also have the cipher functionality. So we can create a cipher, like have a secret, and we can also like write it to a file, so we wouldn't need to worry. And here's how easy it becomes when we use all of these things together. So we have the readable, important stuff here. We pipe it to gzip, it gets really small, even smaller stuff here. And then we pipe it to cipher. So now the important stuff is small and secured. And at the end of the day, we have the right string that will make this file in path.file.txt exist, all ciphered and smaller than before. So this is like the power of the transform string right here. So let's take a look at the new flow with transformations, right? So we have this 24 gigabyte file, really huge. We think that, okay, if we were to store it, we want to make it smaller, and it has important stuff here. So we need to make it secured, and then we want to write it to our server. So readable.pipe to zip, .pipe cipher, .pipe writable. You have all of the things there. Secured, small, and yeah, without having to make the file available in the memory, all the file, all the 24 gigabytes of file. And here we have the factory with direct oil on demand distribution. Forget the oil here. So we have the readable.pipe, oil to diesel, .pipe writable, and the writable would be to his oil drum that he has at home. So now he sees that he's pretty happy here. Thanks, dude. My pleasure. So transform streams, they are really powerful, right? Like a lot of stuff. We can transform, we can do a bunch of things. So it must be the most powerful in terms of features, right? Wrong. We still have the duplex stream. So it is even more powerful than the transform stream. And it's really like where your imagination starts like to shine because you can do all the kinds of things with it. So the duplex stream, it's like a call center. And you can call and talk to it, but at the same time, it may be answering 10 other persons with other subjects. It doesn't need to be the same, what is you're writing and what you're reading. So it's very similar to a transform string, but the reading and the writing doesn't have any correlation. If you write to it, you could be writing to anywhere that you want. If you read from it, you could be reading from anywhere that you want as well. It doesn't need to have any kind of correlation. And it implements basically both the writable and the readable interfaces. So you can do the same thing that we were seeing before with the transform string. But in this case, the transform string implements it to achieve its functionality. So everything that the transform string has is built upon what the duplex string has. Cool. Now let's create a duplex string. So creating a duplex string from scratch or from other strings as well. First, and this is my favorite one, is using the factory method from duplex. So here you add like duplex.from, and then you pass a readable and a writable string. You can do whatever you want at this moment. Like you can already write and read from these two streams that you passed. And yeah, like they don't need to be correlated at all. They will function each of them at their own pace. You can also create your own duplex extending the duplex class, And here you can see like we are implementing the internal write method, underscore write, and the underscore read. And yeah, it will be available for us to read or write at any moment. And we can also pass the new duplex, the write and read functions like this. So same way as the one in the write, but here with the instance instead of extending the class. So now here's where the crazy part starts. So it's a little bit hard to get the head around it. So really try to pay attention. And if you have any questions, you can always reach out to me. Okay, we have the duplex here, and we have a create write stream, right? So let's get started with the text. Sorry. So write, read, and everything else you may want. So the duplex stream, the same as transform, implements both write and read streams. The difference between it and the transform stream is that the writing and the reading between the duplex stream don't need to be related. It can be the opposite, actually. So they could do two completely different operations and never talk between themselves. But depending on the implementation, you can achieve basically pretty much the same as the transform. So here in the example, we have the create write stream, and you have the duplex. And yeah, here we can recreate the write stream. This is going to be our writable. The iterable there, we are going to pass this stuff here. And then we generate the readable from this iterable, so it will yield those values to us. And for example, here I'm using the duplex.from readable, in this case, readable.from iterable, and then the writable that is the create write stream. And when we write to it, what will happen is it will write to the file. It will not do anything with the readable. And when we read from it, it will read from the iterable that we passed. So it doesn't have any correlation at all. Unless we implement this correlation, it will not have it. And now the last part is the piping it up 3.0 and the final pipe. So the end of the series. So now imagine that with this functionality, we can pipe through multiple readable and writable streams, still keeping the same composability, but now without the transform. Instead, we can do any kind of relation to any kind of to any kind of object or whatever you have inside of your application. You have your own logic here. It's basically the most Lego experience that you can have with streams. So here's going to be the crazy stuff. So we have the base iterable and the base readable, right? We create from this iterable crazy stuff base readable. So this is going to be the readable that we are going to be doing the pipe from. And then we create two different readables. So the first one is a readable from stuff here, another iterable. And then the writable is going to be create write stream. And yeah, it will write to the path, to the file in the path. So now we create a duplex from readable and writable. So these two here. And when we call base readable.pipe duplex, what will happen? It will write to the writable stream. So inside of the file in this path here, we will have crazy stuff inside of it, crazy in the next line stuff. And when we try to read from it, it will read stuff here. So basically, we could do something like, okay, we want when the pipe gets executed, when we write to the file, we want to let the user know that it's been written. So we can create this kind of flows whenever we want, and just as easy. It takes a lot of imagination to realize the power of this. And yeah, like this is really where like the Lego experience happens. You can do whatever you want, and yeah, freedom to the developers. And yeah, here is the same diagram that we've seen before, but we can see that they don't talk between each other. Like if you want to implement some kind of communication between them, you can always, but at the end of the day, it's pretty much you need to implement it yourself. So it needs to make sense to you and to your application. Cool, but talk is cheap, Now show the code. So this is a little experiment that I wanted to do with you guys. That is, let's implement the Vin Diesel solution ourselves live right now. So I'm going to share my my VS Code here. First, let's not thank you for now. First, let's take a look at this. So yeah, I have diesel.js here, and cool. We have to implement the oil factory. We have to implement the readable. We have to implement the transform oil to diesel, and we have to implement the writing to the deposit, right? So first, let's get started with implementing the oil factory. So as we remember, it was a oil factory. It is a readable stream. So let's import. Oops. Wrong language. Import readable from stream. Cool. So we have here the readable. And we remember that we can do a readable string from an iterable. So in this case, just to show that we can really implement any kind of iterable here, let's do it with a generator. So we have the oil factory, right? So here, what we're going to do, we're going to do while and here's one of the biggest crimes in programming. So while true, and then we're going to use something of the type diesel and the quantity of 2. Oh, no, but if we remember correctly, the type of the oil factory at the end, it wasn't diesel, it was oil. So we're going to yield the type oil. Cool. Now let's remember how to do the readable part, right? So const readable, let's call oil distribution system. Distribution string equals, yeah, cool. Nice. So oil distribution system string, I mean, so it's going to be a new, not a new, it's going to be a readable dot from, and then we can pass a iterable here, right? But for now, like let's put it like let's put something like this here. Let quantity equals 0, quantity plus plus, and then here like quantity bigger, smaller than 20. This way, for now, we can control the flow of the factory, just so I don't break my computer while I'm doing this presentation. And now we can pass it in here. And yeah, let's take a look at how is it going, right? Let's try to execute this. So we can do console.log oil distribution stream.read, right? And fingers crossed, everything will work. Nice. We have our first read from the oil distribution system. So we can call it as many times as we want, and we will generate it as many times as we want. Cool. So first part, implement the oil factory, done. Now implement the readable. So we can say that this here is the readable. Let's put it here then. Readable from oil factory, so it's already letting us know that it has the oil here, so we can read from it. So now let's implement the transform oil to diesel, right? So cool. Let's call it refine oil to diesel stream. Transform stream. Big names, I know. So here we are going to use the transform string. Oh, not transform string like this. From here. Cool. And here we are going to use the constructor. You transform, and then as we remember, we can pass the transform function here inside. The transform function receives a chunk, an encoding, coding, no encoding, and the callback. Don't forget the callback. If you forget the callback, it will still hang there until the end of time if your application doesn't stop. So, and yeah, right now we need to do something here inside of the oil factory that is object mode true. So we want to have this as our object mode. And same for here in the bottom part, object mode true. Cool. So now we have the transform here. So what can we do? We need to implement a function, right, that transforms our oil into diesel. So let's say const refine oil to diesel. And here we're going to pass oil. And what happens is, oops, we're going to return object that will have type diesel. And here will be the quantity of oil dot quantity /2, because of course, when we transform oil to diesel, like we will have some loss. Cool. So we can pass it here, and we have the chunk, right? And the chunk would be basically this here. So now that we have that, we can do this dot push refine oil to diesel. So now we are going to be pushing into the readable string buffer this refined oil to diesel object. And I think that's it for the part where we transform the diesel, right? So, okay, now we can do the callback and we are good to go. So let's start, let's again try this, what we have written so far. So we have the readable function here, the oil distribution system. And we want to pipe this transform string into this oil distribution system. And here what happens is that if I remember, we can do .on data, and then we can do a callback here, which will, I think we can do just console log if we are wanting to console log this. Cool, nice. So now we have the data being transformed here inside of the transform string. It receives the oil, it changes to diesel, it halves the quantity because we lose some of the oil when we are doing the conversion. And yeah, right now we are forcing it into this oil distribution system, and yeah, you are receiving a bunch of the quantities here of diesel. Cool. So now let me comment this here, and now what's missing? The part where we put the diesel inside of Vin Diesel's deposit, right? So let's think now. If we were to like really implement this, this would need to be an eternal number because, of course, the factory it is producing and yeah, it can produce like a lot of oil. So we need to control on our part what we are consuming or not. So for now, it's going to be acting like a factory while you are asking for oil we will be giving you, and we are going to have to control this on our part, right? So let's get started. First, like we can start with the writable object. So we're going to have the fuel diesel drum writable string that is going to be a new writable. And here again, we are going to be passing object mode true because we want to work with it like an object. And then we are going to have the write object here, the write function here. And what we want to do with this write function. If we remember from the presentation, it can have, again, a chunk, an encoding, and a callback, right? Cool. It can have all of this. And I forgot to import writable here, so that's why it's not colored up. Cool. So now we have chunk, encoding, callback. And here we are writing it to our drum. So let's say here, let's create a deposit. A deposit equals type diesel, and then quantity 0, because it starts with 0. It's a brand new deposit, you know. So now let's make this constant, as we aren't going to be changing the object reference per se. So now we can do like pretty easily deposit dot quantity equals deposit dot quantity plus chunk dot quantity. Yeah, I think that every time we receive a chunk, we sum this with the quantity of the deposit, and this is going to be the new quantity of the deposit. So what we can do is use the callback here, and fine. But here we aren't going to have the callback. We aren't going to have the flow control, right? So what we can do is try to think about a way of how we can pause this functionality of happening. So if we remember correctly, there is this two methods that we can implement. They are pretty easy to implement, like the pause and the resume methods that we can pause a string. So we can do that as well. So here, for example, if our let's call const new quantity equals this here. So if our new quantity is bigger than 10, that is the limit that we want right now, then we can do a string oil distribution string. That is the first string that we are getting stuff from, not false. So what should happen now is that when we get to this new quantity, the string should pause and it shouldn't run the next line. So we are going to return here. Return callback. Because otherwise it will hang forever. Okay, so let's see. Oil distribution string, right? Dot refine dot pipe. And fuel diesel drum with writable string. So now let's see what is going to be the next quantity, the new quantity here. And let's see if it will stop before it reaches the quantity of 10. So console.log. Cool, so it's reaching 11. What happens is that when it reaches here, it will be already summing. So basically, if we put it this here, it would be 10. And yeah, it's not passing. So, and we have basically an eternal thing here that it's running forever. And whenever we unpause it, it will stop, continue to run it again. We could also implement the part where the Bervin diesel brings the diesel, but I think that we are a little bit over time right now. So I would like to get back into the presentation and yeah, say thank you. Thank you very much if you participated here. If you don't participated and you are seeing this video later, then thank you again for seeing this. If you have any doubts, if you have any questions, I know that's kind of a really, really big subject and it needs a lot of study. So if you have any questions, you can reach out to me. And yeah, thank you very much.